Yeah, good afternoon to one and all.
Good afternoon, sir.
Good afternoon, sir.
Yeah, today we are going to discuss about the natural hazards, earthquakes. Yesterday, we have discussed that one which is volcanoes, and today we are going to discuss about the earthquakes. So this is also one of the important and most dangerous natural hazard. So generally, an earthquake is a sudden vibration of the Earth's surface by rapid release of energy. So generally, you are seeing the news and we are reading the newses in the newspaper, and also we are watching the TVs. There are several earthquakes are reported throughout the world, and how the dangerous and hazardous activities are takes place. And this is very familiar to us, the name earthquakes. So the earthquake is a sudden vibration. It is a sudden vibration of the Earth's surface by rapid release of energy. So any earthquake, it occurs itself and suddenly. So it is a sudden vibration of the Earth's surface. As we know, when the way the earthquakes are occurred, that place or that area, it has been split away from one another. Yes. So it is a sudden vibration. The sudden vibration of the Earth's surface by rapid release of energy. So this energy is released when two parts of rock masses. How this energy is released? When the two parts of rock masses move suddenly in relation to each other along a fault. So I think instead of this, you need to learn about the fault and folds, joints, unconformities. So these are the structural features. So fault is a black, the movement of black is known as fault. The movement of blacks. So it means any huge rock masses or any huge material which is going to be split away from one another is called fault. So it is, before that, it is a uniform material. Once fault is occurred, so any fracture, so that fracture is widely distributed or widely enlarged or extended, and it has been moved away from one another. So this is fault. So generally the earthquakes required energy, the huge energy. So that energy in the form of vibrations on the earth surface, so that the earth splits away from one another. So this energy is released when two parts of rock masses move suddenly in relation to one another along a fault zone. So when the rock masses are moving one another or one away from one another, so in which way the huge amount of energy is going to be released? This energy in the form of vibrations, which has been takes place on the earth surface. So that in this way, the earthquakes are occurred. So it needs some energy. So that energy is suddenly vibrates in the form of vibrations. It has been takes place from the at greater depths to the earth surface. So in this way, the earthquakes are occurred by amount of energy it required to occur the earthquakes or to take place the earthquakes. So what are the effects? Is there an effects of earthquakes? So is there any effects of earthquakes? Yes, definitely. The earthquakes affects in a large scale. So the important earthquakes effects are mostly the buildings are damaged. Due to earthquakes, the buildings are damaged. And also, mostly, then people get frightened. The people get frightened. It means the people are mostly scaring about the earthquakes. Isn't it the fear about the earthquakes in a people? So generally, the people get fearing about or scaring about the earthquakes. And roads are fissured. Roads are Fissured means they are disturbed. The roadway lines, the railway lines, isn't it? They are disturbed. The roads are fissured. Railway lines are twisted, and bridges are destroyed. Due to earthquakes, the road lines or roads are fissured. It makes depressions or making some dumps, and railway lines are twisted and are tilted or twisted, and bridges are destroyed. So whatever the construction, whatever formations which are going to be deformed. So due to earthquakes that place, it is going to be deformed. So in mostly in cities, so the ground waves disturb the underground services and start fires. Most in cities, mostly the ground waves, the earthquakes ground waves, which is going to be disturb the underground services and start underground services, mostly the water lines, current lines, and mostly the tunnels, isn't it? The underground drainages, they're all going to be disturbed due to earthquakes. So in cities, mostly the ground waves disturb the underground services and start fires, and the rivers change their courses. Due to earthquakes, the rivers change their course. For example, river, it has a channel, river, it has a valley. So river flows in a valley regions. So due to earthquakes, river course has been changed. The river channels, which are going to be changed their pattern because of a disturbances are occurred in the regular course of the river. Isn't it? The fissures are opened up in the ground, which may cause springs. So generally, the fissures nothing but vesicles, nothing but holes, isn't it? So the fissures are opened up in the ground or the open earth surface, so that it may cause springs. Springs and then what you can call it as in Telugu, mostly springs means Uta Buggalu. Generally the groundwater will be flowing on the earth surface. So the groundwater itself flowing on the earth surface without any submersible pumps. So which is called springs. So due to the fissures are opened up on the ground, so that what happen, the ground which may cause springs on the ground, which may cause to springs also. So generally the permanent tilting of the land mass, may occur in certain areas. Landslides may occur in hilly regions. The landslides may occur in hilly regions also. And also we should know the basic terminology in the earthquakes. So here, first let us know the focus. So focus is a point of origin of an earthquake within the earth crust is called the focus. So there are majorly 3-4 terms are very, very important in earthquakes. So just try to learn. The first one, focus. So focus is a point of origin of an earthquake within the earth crust. Focus is a point of origin of an earthquake. Ekkadaithe earthquakes origin unte means where it is originates. So the focus, the point of origin of an earthquake within the earth crust is known as focus. From this focus, the earthquake's waves. From this focus, generally the earthquake's waves are radiate in all directions. From this focus, the earthquake waves, which are originate or which are radiate in all the directions, which is called focus. So let me show some diagram so that you can able to understand very easily. Let me share my screen share so that you can able to understand very clearly. Yeah. Yeah, are you able to see this picture?
Yes, sir.
Yeah, figure 2.39 showing a focus, epicenter, and isoscemal lines. So this figure is going to be show about the focus, epicenter, and isoscemal lines. Okay, so we are talking about the focus. I will see this. This is the focus below the point. Okay, so focus is a point of origin of an earthquakes. ఎక్కడైతే earthquakes సంభవిస్తాయో, ఎక్కడైతే earthquakes ఉద్భవిస్తాయో, the point of origin of an earthquake within the earth crust. Remember, within the earth crust. So not above, within the earth crust means below the earth surface. Crust, you know the depth of the crust, it is about 1 to 75 kilometers from the ground surface, from the earth surface to up to 75 kilometers the crust thickness, whereas in the continental region, okay, so the crust is that much of thickness. So from 1 to up to 75 kilometers below the earth surface, this is crust. From 75 to 2900 kilometers, that is mantle. Okay, so like that the crust thickness is about 75 kilometers. So focus is the point. Try to understand, this is a very essay question, definitely comes in your question paper. Okay, focus is a point of origin of an earthquake. So focus is the point of origin of an earthquake within the earth crust is known as focus. From this focus, the waves, earthquake waves are radiate in all the directions. So ఈ ఫోకస్ పాయింట్ నుంచి ఎక్కడైతే ఎర్త్క్వేక్ సంభవిస్తుందో, ఎక్కడైతే ఎర్త్క్వేక్స్ రేడియేషన్స్ జనరేట్ అవుతాయో, from that point the earthquake waves are radiating in all the directions. That is about the focus. Clear? Next, coming to epicenter. So the epicenter is the point lying vertically above on the earth surface. Epicenter is a point lying vertically above on the earth surface, directly above the focus, is called the epicenter. I will see this. Focus exact vertical epicenter above point, upper point, epicenter. Yes, are you able to viewing all of you?
Yes, sir. Yes, sir.
Yeah. So this epicenter is the point lying vertically above on the focus, directly above on the focus, which is called epicenter. So this epicenter is on earth surface. This epicenter is on the earth surface. So there are two differentiations between the focus and epicenter. Focus below the earth crust or below the earth surface, and epicenter above the earth surface. Understand? So focus is a point where the earthquakes are started below the earth crust or below the earth surface, and epicenter is a point where the earthquakes are end, or it is a vertical point above the directly on the focus, which is above the on earth surface. This is epicenter. It means, so whatever the breakage of land or area on the earth surface, that point is epicenter, which we are seeing, which we can able to see on the earth surface, which we can able to see on the land, on the surface. So that is epicenter. So ekkadaithe manaku bhoom paina pagulutunnattu kanipistundi, that point which is epicenter. Okay, So in the epicenter, the shaking is most intense. In the epicenter, the shaking is the most intense. The intensity gradually decreases outwards. The intensity gradually decreases outwards. Ekkada exact ga where the epicenter takes place, from there it is going to be extend. So the intensity is gradually decreases. ఎక్కడైతే ఎగ్జాక్ట్ గా ఎపిసెంటర్ ఏర్పడుతుందో అక్కడ ఇంటెన్సిటీ బాగా ఉంటుంది. ఎర్త్ క్వేక్స్ ఇంటెన్సిటీ ఇస్ వెరీ హై, బట్ ఇట్ ఈస్ గ్రాడ్యువల్లీ డిక్రీజ్ టు ఫర్దర్ ఎక్స్టెన్షన్. కానీ ఆ పాయింట్ నుంచి నువ్వు దూరం పోతున్న కొద్ది ఏమవుతుంది, దట్ హెస్ బీన్, ఇట్ ఈస్ గోయింగ్ టు బి డిక్రీజ్ ద ఇంటెన్సిటీ, ఇజంట్ ఇట్? సో సింపుల్ ఎగ్జాంపుల్, వేర్ ఇట్స్ ఎగ్జాక్ట్లీ ఫైరింగ్, ఎక్కడైతే మంట బాగా మోతుంది అనుకోండి, అక్కడ హై టెంపరేచర్ ఉంటుంది. సో from there to just moving towards far from that point, the temperature is gradually decrease. Another. So where it's firing, so if you stand near that place, you feel very high temperature. When you are moving from away from that point, definitely the temperature will be decreases, isn't it? So like that is epicenter, focus and epicenter. So focus is a point where the earthquakes are originated, and from this focus, the earthquakes waves are originated or radiate in all the directions. And epicenter is a point which is vertically lying directly above the focus, which is on the earth's surface. So in the epicenter, the shaking is most intense. In the epicenter, or the point of epicenter, the earthquake's intensity is very more. When we are moving, or the intensity is gradually decreases outwards or further extension. Okay, that is epicenter. Then coming to isoseismal lines. Isoseismal lines. I will see this. So these are the isoseismal lines. I will see this. Ring-like structures. Okay. So these ring-like or equal elevations. So these are the disconnected points, are the equal elevations on the earth surface. So see, so what is it mean by isoseismal lines? So the lines connecting points of equal intensity. The lines connecting points of equal intensity on the ground surface are called isoseismal lines. So the isoseismal lines are the lines connecting points of equal intensity on the ground surface, which are called isoseismal lines. So already we are talking about the intensity is decreasing from the point of epicenter. So epicenter నుంచి మనం దూరం పోతున్న కొద్దీ ఎర్త్క్వేక్స్ ఒక ఇంటెన్సిటీ తగ్గుతుందని చెప్పుకున్నాం. సో కాబట్టి from the point of epicenter to outwards, బయట వైపులా ఆటోమేటిక్ ఏముంటది, different intensities are there. So we are connecting the equal intensity points or equal intensity connecting points, isn't it? The lines connecting the points of equal intensity on the ground surface. So a భూమి పైన ఉన్నటువంటి ఈక్వల్ ఇంటెన్సిటీ పాయింట్స్ ను కనెక్ట్ చేసుకుంటూ గీసినటువంటి imaginary lines, which are called isoseismal lines. సో ఎపిసెంటర్ నుంచి మనం భూకంపం సంభవించింది ఎక్కడ, ఇట్ ఈస్ ఆన్ ది అబోవ్ ది ఎర్త్ సర్ఫేస్. సో అక్కడ నుండి అక్కడే ఉండదు కదా, కొంత కిలోమీటర్ల వరకు కూడా దాని యొక్క ఇంటెన్సిటీ ఉంటుంది. బట్ ఆ ఇంటెన్సిటీ ఏమవుతుంది, ఫ్రమ్ ది పాయింట్ ఆఫ్ ఎపిసెంటర్ టు అవుట్వర్డ్, దూరం పోతున్న కొద్ది క్రమక్రమంగా గ్రాడ్యువల్లీ డిక్రీజ్. ఎస్, సో కాబట్టి ఇంటెన్సిటీ వేరు ప్లేస్లలో అంటే వీఆర్ గోయింగ్ ఫ్రమ్ epicenter to the outwards, the intensity is gradually decreases. So there are several intensity ranges has been takes place from the point of epicenter to towards the end point of outward of the earthquake. So ఈ భూమి ఉపరితలం పైన ఉన్నటువంటి ఈక్వల్ ఇంటెన్సిటీ పాయింట్స్ కలుపుకుంటూ గీసినటువంటి imaginary lines. So the lines connecting points of equal intensity on the ground surface are called isoseismal lines. If the focus is a point, if the Focus is a point. The isoseismal lines will be a circles, but as the focus is commonly a line, the isoseismals are generally a elliptical in size. From the distribution of the lines, the epicenter of an earthquake can be determined. So the epicenter from these lines, from the isoseismal lines, so we are connecting the equal intensity points. We are drawn a isoseismal lines. So from these isoseismal lines, from ending point nunchi equal intensity points kalpukuntu we are drawn a circles or elliptical lines. So we kalpukuntu chivari varaku vachesariki emaithe manaku we can determine the epicenter ana kada. So chivari nunchi equal elevations, equal intensity earthquakes ni kalpukuntu manam up to we can determine the epicenter point. So from the distribution of the lines, the epicenter of an earthquake can be determined. Then earthquake's intensity. So it is a measure. It is a measure of the degree of destruction caused by an earthquake. What is an earthquake intensity? What is an earthquake intensity? Isn't it? So intensity means it is a tivrata. So how much amount? Isn't it? It is a measure of the degree of destruction. It is a measure of the degree of destruction caused by an earthquake. So what is an earthquake intensity? It is a amount of degree of destruction caused by an earthquake. So earthquake valla జరిగినటువంటి నష్టాన్ని మనం ఏమంటాం డిగ్రీ ఆఫ్ డిస్ట్రక్షన్ ఎంత మేరకు అయితే నష్టం జరిగిందో దాన్ని ఏమంటున్నాం మనం we can call it as earthquake's intensity. Understand? So the degree of destruction, the amount of degree, ఎంత అమౌంట్ లో నష్టం జరిగింది which is caused by an earthquake. ఆ యొక్క ఎర్త్క్వేక్ వల్ల ఎంత అమౌంట్ లో మనకు నష్టం జరిగింది అనేది తెలిపేదాన్ని ఏమంటారు మనం ఇంటెన్సిటీ. ఎర్త్క్వేక్స్ ఇంటెన్సిటీ, ఎర్త్క్వేక్స్ యొక్క భూకంపం యొక్క తీవ్రత. So it is expressed by a number as given in the earthquake's intensity scale. How we are going to express the intensity? It is expressed by a number as given in the earthquake's intensity scale. There is a intensity scale is there. So on that scale, we can mention that number. Depends upon the degree of destruction which is caused by an earthquake. Understand? So earthquakes వల్ల జరిగిన నష్టాన్ని మనం భూకంప స్కేల్ పైన నెంబర్ల మీద చూపిస్తాము. It is reported on the scale of an earthquake scale. So this is about earthquake's intensity, isoseismal lines, epicenter, and focus. So these are the major 4 terms in earthquakes we should remember definitely. What is focus? What is epicenter? What is isoseismal lines? And what is earthquake's intensity? So these are the major terms we should learn if you want to know about the earthquakes clearly. Okay, clear, all of you?
Yes, sir.
Then coming to seismographs.
Yes, sir.
Okay. Yeah, then coming to seismographs. So here, generally, the seismograph, I will see this, I will also show. So this is seismograph. Yes. Are all viewing this diagram? Figure 2.40, seismograph. Yes. Yeah. So what is seismographs? So seismographs are the instruments which are detect and record earthquake waves. So seismographs are instruments which are going to be detect and record the earthquake waves. The most of the seismographs, mostly They contain heavy weight suspended from a support. So you can see the diagram. So seismograph, the instrument, which is an instrument. This instrument which is going to be detect and record the earthquake waves. So this instrument is going to be record and detect where earthquakes are occurred, and record the earthquake waves. So it is going to be record the earthquake waves as well as it is going to be detect the earthquakes. So this instrument, seismographs are the instruments which are going to detect the earthquakes and also record the earthquake waves. So this instrument, seismographs, contain a heavy weight suspended from a support. Heavy weight. Have you see this? This is weight. In the diagram, like a needle-like structure of huge weight. So that is weight. Okay. So this weight has been supported by the wire to the stand pillar. Okay, this is pillar. This is a pillar. From the pillar, it has been connected the wire, and that wire connected to the heavy suspended a support, weight suspended, heavy weight suspended from a support. Okay, this is mirror and this is recording drum. The circular one is recording drum. So this is a light source, and this is a light source, and this is the mirror, and this is the heavy suspended weight. Okay, so this is the seismograph instrument which is going to detect the earthquakes as well as it is going to record the earthquakes waves. So which is attached to a bedrock. So this pillar which is going to be attached to a bedrock mostly. Then when the waves from a distant earthquakes, reach the instrument. So the inertia of the weight keeps it stationary while the earth and the support vibrate. So the movement of earth in relation to the stationary weight is recorded on a rotating drum. How this instrument is going to be record earthquakes means, so if when the earthquakes are occurred, so these earthquakes waves from distant earthquakes waves, which is going to be, these earthquakes waves are going to be reach the instrument. So instrument akkada lekapoyinappatiki somewhere the instruments are installed. So these earthquake waves are going to be reach to the instrument, and inertia of the weight keeps it stationary. So that weight, the heavy weight in there, that weight keeps it stationary while the earth and the support vibrate. So the pillar, earth, and the support vibrates. So whatever the support is going to vibrate. Pillar in the pillar, it is installed in the earth. So when the earth is moving or when the earthquake waves are reached this place, this pillar is going to vibrate so that the heavy weight is also going to be shake or vibrates, so that mirror is observe the waves on the recording drum, and the recording drum is going to be record the intensity. The drum, according to earthquake's intensity or according to how much amount of vibration takes place on that place, as according to that a drum is going to be record the intensity. So the movement of the earth in relation to the stationary weight is recorded on a rotating drum. So the movement of earth, so how the movement has been takes place on the earth surface on relation to the stationary heavy weight is recorded on a rotating drum. So in order to vibration or in order to movement of the earth surface in relation to the stationary or in relation to the instrument, weight is going to be recorded on rotating drum. So some seismographs detect horizontal motion. Some seismographs detect horizontal motion while others detect vertical motion. There are some instruments, seismograph instruments, some are going to be detect the horizontal motion. The lines are waves are horizontal motion record chestayi. Some other instruments which are going to detect the vertical motion. So the trace of the earthquake waves usually recorded on a traveling photographic paper as a series of zigzag lines. So this is how it is going to be showing the horizontal seismograph. See the figure 2.41 seismograph. Have you seen this? So on the rotating drum, it is going to be detect the horizontal. This is horizontal one. Horizontal motion. Have you seen this? So this is the lines, zigzag lines. Isn't it just like heartbeat just showing in, isn't it? So same as it is zigzag lines, which is going to this is horizontal motion detect in the seismograph. Some seismographic instruments are going to detect the vertical lines also. Okay. So this is how the rotating drum or instrument or seismogram, which are going to be detect the earthquake waves, and it is recorded the earthquake waves and their intensity. So these records are called seismograms. Seismograms. Seismograms and seismographs. Seismographs are the instrument. Seismograms are the these records are called records name seismograms. So seismograms are generated by seismographs. Seismograms are generated by seismographs. Seismographs are the instrument, and seismograms are the records which is prepared by seismograph. So from the seismograms, the time interval between the arrival of the P and S waves can be calculated, and with the help of the travel time graph. So the distance between the recording station and the epicenter is determined. So from the arrival of the P and S waves, P wave and S wave, see this. This is P wave, this is S wave, and this is surface waves. Okay. There are three types of waves are there: P waves, S waves, and surface waves. Okay. So when the P and S waves can be calculated, and with the help of the travel time graph, the distance between the recording station which are going to be seen up to epicenter. Okay. So generally, earthquake waves. Coming to what are the earthquake waves? What are the earthquake waves? As we know, the earthquake waves, during an earthquake, the seismic waves are generated, which spread outwards in all the directions from the focus. The seismic waves are three types. The seismic waves are seismic or seismic or earthquake waves. The seismic waves are three types. They are P waves, S waves, and surface waves. Okay. And there are how many types of earth waves are there? Waves are there? There are three types of waves: P waves, S waves, and surface waves. So here, the surface waves are responsible for causing earthquakes, while the main significance of P and S waves is in the study of the Earth's interior. So the surface waves are main reason or main cause or main responsible for causing earthquakes, while the main significance of P and S waves, which are useful in the study of Earth interior. Earth's interior study చేయడానికి ఏమో మనకు P waves and S waves use అవుతాయి. So the main significance of the P and S waves are to study about the Earth's interior or interior of the Earth. But whereas surface waves are main responsible for the causing of earthquakes. Okay. P and S waves travel through the interior of the Earth and reflected and refracted as they enter a layer of the different materials. So these are the three types of waves: P waves, S waves, and surface waves. Let us do the first one, P waves. P waves are also known as primary waves. P waves are also known as primary waves. Yeah, let us see. So generally, coming to P waves, first one, P waves. So here, the P waves mostly, you can say, P waves are also known as primary waves. P waves are also known as primary waves. These are compositional waves which cause the particles of rock. So generally, the P waves mostly we can see, which is going to be where the cause of particles of rock to vibrate in the longitudinal direction. The P waves travel fastest, therefore they reach a seismic station first. So velocity of P waves or primary waves is very fast. So that is why these P waves are reached the station or seismograph first. So generally their velocity is 1.7 times than that of S waves. So their velocity is 1.7 times greater than that of S waves. S waves velocity kante P waves velocity 1.7 times ఎక్కువగా ఉంటుంది. So almost 8 kilometers per second, I think. The P waves velocity is 8 kilometers per second. So fastest velocity, high velocity than other waves. Then coming, and also the P waves pass through solids as well as liquids. P waves దేంట్లో pass అవుతాయి? It can pass through liquids and gases. Okay, I mean solids. It can pass through solids and as well as liquids. So ఘన పదార్థాల్లోనూ మరియు ద్రవ పదార్థాలు both media they can pass the P waves. So velocity is very high. It can pass through solids and liquids and longitudinal directions. Okay. Next, coming to S waves. S waves are also called as secondary waves. S waves are also called as secondary waves. So these are shear waves. Secondary waves, and these are the shear waves which are transverse in nature. Ivi addanga prayanis, which are transverse in nature. Whereas P waves are longitudinal direction, whereas S waves are transverse in nature. So their velocity is less than the P waves. Already I told that their velocity is less than the P waves. The S waves travel through solids only. S waves దేంట్లో ప్రయాణిస్తాయి? Only solids and do not pass through liquids. And these waves do not pass through liquids. Whereas the P waves are pass through liquids and solids, S waves pass only through solids. Then coming to L waves, third one. L waves are also called as surface waves. Third one, surface waves. Surface waves are also called as L waves, are also called as long waves. Long waves. That's why it is represented as L waves. Okay. When P and S waves reach the Earth's surface, they are converted into L waves. Chudandi. When the P waves and S waves reach to the Earth's surface, then they are converted to L waves. The L waves travel along the surface and cause earthquake. So this is how the earthquakes are happening. ఎప్పుడైతే P waves and S waves, when they are reached to the Earth's surface, then they are converted into L waves. So these L waves travel along the surface and cause earthquake. Along the surface, they travel along the surface so that it can main cause to the cause of an earthquake. They are transverse in nature and their velocity is much less than the P and S waves. So this is also transverse nature. P waves longitudinal nature, longitudinal direction. S waves transverse direction, and even L waves also transverse in direction, and their velocity is very low than the P waves and S waves. And this is about the earthquake waves or seismic waves. Okay. Then classification of earthquakes. Classification of earthquakes. So classification is depending upon their mode of origin. The earthquakes are classified into following groups. So generally, mode of origin. Based on the mode of origin, the earthquakes are classified into three types. They are earthquakes due to surface causes. First one. Second one, earthquakes due to volcanic causes. And third one, earthquakes due to tectonic causes. Because it depends upon the mode of origin. అవి ఏర్పడేటువంటి విధానాన్ని అనుసరించి there are three types. Earthquakes due to surface cause. Second one, earthquakes due to volcanic causes. Third one, earthquakes due to tectonic causes. Surface వల్ల ఏర్పడితే surface earthquakes అంటున్నాం. Volcanoes వల్ల ఏర్పడితే volcanic earthquakes అంటున్నాం. And tectonic వల్ల ఏర్పడితే tectonic earthquakes అంటున్నాం. And second classification is based on the depth of the focus. Second classification is based on the depth of the focus. Focus అనుసరించి. So the earthquakes are divided into the three types. One is shallow focus earthquake. Try to understand carefully. Based on the mode of origin, three types. Earthquakes due to surface cause. Earthquakes due to volcanic cause. Earthquakes due to tectonic cause. These are the three types which are based on the mode of origin. The second classification is based on the depth of the focus. Focus యొక్క depth అనుసరించి. There are also three types. First one is shallow focus earthquakes. Shallow focus earthquakes. Second one is intermediate focus earthquakes. Intermediate focus earthquakes. Third one is a deep focus earthquakes. Deep focus earthquakes. Shallow focus earthquakes, intermediate focus earthquakes, and deep focus earthquakes. So let us see the first one, shallow focus earthquakes. Earthquakes having depth of focus up to 55 kilometers. The earthquakes having depth of focus up to 55 kilometers. So up to 55 kilometers ఉన్నటువంటి up to 55 kilometers ఉన్నటువంటి డెప్త్ వరకు ఉన్నటువంటి ఫోకస్ ఉన్నటువంటి ఎర్త్క్వేక్స్ ఏమంటాం మనం షాలో అంటే వెరీ నియరర్ టు ద అర్త్ సర్ఫేస్, భూమికి చాలా దగ్గరగా, which are called shallow focus earthquakes. The focus depth is up to 55 kilometers. Then second one is intermediate focus earthquakes. The earthquakes having depth of focus between 55 to 300 kilometers. 55 to 300 kilometers. From the 55 nunchi up to 300 kilometers having of depth of focus is called intermediate focus earthquakes. Okay. Next, third one, deep focus earthquakes. Deep focus earthquakes. So these deep focus earthquakes, which means the name itself indicating deep means at a great depth. Okay. Deep focus, earthquakes having depth of focus between 300 to 650 kilometers. The earthquakes having depth of the focus between 300 to 650 kilometers. So such type of earthquakes are called deep focus earthquakes. So the shallow earthquakes are more violent. The shallow earthquakes are among these three, shallow, intermediate, and deep. Among these three, the shallow earthquakes are more violent at the surface, but affect a smaller area. At the surface, but affect a smaller area than deep earthquakes. So earthquakes are more violent, shallow focus. Why? Because they are very nearer to the earth surface. Yes, they are very nearer to the earth surface. So that is why very nearer, so that the earthquake intensity is very high. So earthquake intensity, when it is high, definitely that they are very violent. Okay. Once again, shallow focus earthquakes up to 55 kilometers of focus depth, intermediate earthquakes up to 55 to 300 kilometers focus depth, and deep focus earthquakes are 300 to 650 kilometers of the depth of the focus. Okay, so this is about classification of earthquakes. Okay, then coming to see the earthquake scale. So the earthquakes intensity is measured, as I already discussed. Earthquakes intensity is measured by the scale, yes, and earthquakes intensity is measured a number, a degree of destruction. The amount of degree of destruction which is caused by an earthquake is called earthquake's intensity. So this earthquake's intensity is measured by the earthquake's intensity is measured by scale, by showing a number. So there are several scales are there, but mostly we are using a Richter scale. Most of the times you might to see in the you are going to be seeing the watching the televisions. So sometimes you are reading in the newspapers also. You are seeing in the televisions also. So Richter's earthquakes are occurred, and Richter scale is reported as 6.5, 5.7 like this. Yes. So let us see. So this earthquake's intensity scale was devised by Charles F. Richter. So the Charles F. Richter, an American seismologist, it is based on the total amount of energy released during an earthquake. It is measured. This instrument is based on the total amount of energy released during an earthquake. This energy is called magnitude. This energy is called magnitude. So the magnitude is calculated mathematically using the amount and duration of ground vibrations as recorded by a seismograph. During the earthquakes, the seismograph already we have seen the instrument. So instrument దగ్గర a Richter scale ఉంటుంది. ఈ Richter scale ఏం చేస్తుంది? ఎనర్జీని క్యాలిక్యులేట్ చేస్తుంది. The total amount of energy released during an earthquake. ఎర్త్క్వేక్ సంభవించిన సమయంలో టోటల్ ఎనర్జీ ఎంత రిలీజ్ అయిందో ఆ ఎనర్జీ, దిస్ ఎనర్జీని ఏమంటాం మనం? magnitude calculated mathematically using the amount and duration of a ground vibrations as recorded by a seismograph. So here in the Richter scale, so generally the magnitude and their effects. Richter scale by magnitude nothing but intensity or energy. Magnitude nothing but energy. So the amount of energy or magnitude and how it is going to be affect. Let us see. So for example, magnitude means nothing but energy. The amount of energy is released during the earthquakes. For example, magnitude value 2.5 ఉంది అనుకోండి. For example, magnitude value is 2.5. Generally not felt but recorded. Richter scale పైన 2.5 magnitude కనుక రిపోర్ట్ అయిందంటే ఎఫెక్ట్ ఏముంటది? నథింగ్ ఎఫెక్ట్. ఏ ఎఫెక్ట్ ఉండదు. జనరల్లీ నాట్ ఫెల్ట్ బట్ రికార్డెడ్ అంటే ఏదైనా వస్తువులు వైబ్రేషన్ వల్ల 2.5 మ్యాగ్నిట్యూడ్ వైబ్రేషన్ వల్ల ఎలాంటి వస్తువులు కానీ కింద పడడం కానీ జరగదు. కానీ రిక్టర్ స్కేల్ పైన రికార్డ్ అవుతుంది, ఆ సిస్మోగ్రాఫ్ పైన రికార్డ్ అవుతుంది వాల్యూ. నెక్స్ట్ 4.5 లోకల్ డ్యామేజ్. మ్యాగ్నిట్యూడ్ కనుక 4.5 ఉంటే లోకల్ డ్యామేజ్ అంటే చిన్న చిన్న డ్యామేజ్ జరుగుతుంది, అంటే పైన ఉన్నటువంటి వస్తువులు కింద పడడం అట్లాంటివి జరుగుతాయి, లోకల్ డ్యామేజ్ జరుగుతుంది. నెక్స్ట్ మ్యాగ్నిట్యూడ్ వాల్యూ 6.0 కనుక ఉన్నట్లయితే కెన్ బి డిస్ట్రక్టివ్ ఇన్ పాపులేషన్ రీజియన్స్. బాగా క్రౌడెడ్ రీజియన్స్ లో, బాగా పాపులేషన్ ఉన్నటువంటి రీజియన్స్ లో మాత్రం కొంచెం డిస్ట్రక్షన్ బాగా జరుగుతుంది. నెక్స్ట్ 7.0 ఉన్నట్లయితే మేజర్ ఎర్త్ క్వేక్స్ ఇన్ఫ్లిక్ట్ సీరియస్ డ్యామేజ్. ఎప్పుడైతే రిక్టర్ స్కేల్ పైన 7.0 కనుక నమోదైందని చెప్తే ఇట్ ఈస్ ఎ మేజర్ ఎర్త్ క్వేక్స్. సో మేజర్ ఎర్త్ క్వేక్స్ వల్ల మేజర్ డ్యామేజ్ జరుగుతుంది, సీరియస్ డ్యామేజ్ జరుగుతుంది. మోర్ దాన్ 8 ఉంటే గ్రేట్ ఎర్త్ క్వేక్స్ కాజ్ టోటల్ డిస్ట్రక్షన్. ఇది ఇంటెన్సిటీ వాల్యూస్. 2.5 unte nothing happened, but recorded in the seismograph. 4.5 అంటే లోకల్ డ్యామేజ్, చిన్న చిన్న వస్తువులన్నీ సెల్ఫ్స్ నుంచి కింద పడిపోవడం, ఇట్ ఈస్ గోయింగ్ టు ఫెల్ డౌన్. ఓకే, లోకల్ డ్యామేజ్ జరుగుతుంది. 6 ఉంటే బాగా క్రౌడెడ్ రీజియన్స్ లో డిస్ట్రక్షన్ బాగా జరుగుతుంది. అప్ టు 7 ఉంటే ఇట్ ఈస్ ఎ మేజర్ ఎర్త్ కేక్స్ అండ్ సీరియస్ డ్యామేజ్ జరుగుతుంది. అంటే బిల్డింగ్స్ కూలిపోవడం, అపార్ట్మెంట్స్ కూలిపోవడం, ట్రీస్ ఆర్ గోయింగ్ టు బ్రేక్ డౌన్, ఇవన్నీ జరుగుతూ ఉంటాయి అప్ టు 7 ఉంటే. దెన్ మోర్ దాన్ 8 ఉంటే ఇట్స్ ఎ గ్రేట్ ఎర్త్ కేక్స్. ఇట్ కెన్ కాజ్ ఎ టోటల్ డిస్ట్రక్షన్, చాలా లాస్ ఆఫ్ ప్రాపర్టీస్, చాలా రకాలుగా నష్టపోవాల్సి వస్తుంది అప్ టు 8 ఉంటే. సో దిస్ ఈస్ అబౌట్ ద రిక్టర్ స్కేల్. అందుకని మనకు అప్పుడు టీవీలో చూస్తూ ఉంటాం, సో అండ్ సో ప్లేస్ లో భూకంపం సంభవించింది, రిక్టర్ స్కేల్ పైన 5.6 గా నమోదైందని చెప్పి వస్తుంటాయి. ఇంత రిక్టర్ స్కేల్ మోస్ట్ వీఆర్ యూజింగ్ రిక్టర్ స్కేల్. ఇందులో మనకు రోసిఫోరల్ స్కేల్, మెర్కాలి స్కేల్ అని ఉంటాయి, కానీ మోస్ట్లీ మనం కాబట్టి అందుకని మనకు ఎప్పుడైనా ఎక్కడ ఎర్త్క్వేక్ వచ్చినా కూడా ఫస్ట్ సో అండ్ సో ప్లేస్ లో పలానా గుజరాత్ లో రిక్టర్ స్కేల్ భూకంపం సంభవించింది, సో ఇది రిక్టర్ స్కేల్ పైన 5.6 గా నమోదైందని చెప్పి చెప్పడం జరుగుతుంది. అంటే ఈ స్కేల్ పైన నమోదైనటువంటి ఇంటెన్సిటీని ఆధారంగా చేసుకుని మనం అది ఎంత పెద్ద ఎర్త్ కేక్స్, నార్మల్ ఎర్త్ కేకా, డేంజరస్ ఎర్త్ కేకా, ఆర్ గ్రేట్ ఎర్త్ కేక్సా, ఆర్ మేజర్ ఎర్త్ కేక్స్ అని మనం వీ కెన్ ఏబుల్ టు ఎస్టిమేట్, అంచనా వేయగలుగుతాం. అంటే ఏంది దీనికి, జనరల్ గా వీ కాంట్ స్టాప్ ద ఎర్త్ కేక్స్, ఓన్లీ వెన్ ద ఎర్త్ కేక్స్ ఆర్ అక్కర్డ్ దెన్ ఓన్లీ వీ కెన్ మెజర్ ద ఇన్స్ట్రుమెంట్స్ ఆర్. మనకు ఎర్త్ కేక్స్ సంభవిస్తే అని కూడా మనకేం తెలియదు. సో ఎప్పుడైతే ఎర్త్ కేక్స్ సంభవించినప్పుడు మాత్రమే ఈ సీస్మోగ్రాఫ్స్ కాడికి, అంటే మనకు ముందస్తుగా సో అండ్ సో ప్లేస్ లో ఎర్త్ కేక్స్ జరుగుతుంది లేదా జరగబోతుంది అని చెప్పి మనకు టెక్నాలజీ రాలేదు ఇంతవరకు కూడా. టిల్ టుడే we don't have that much of technology to estimate or imagine the before going to occur the earthquakes, isn't it? అంటే ఎర్త్కేక్ ఎందుకు తెలియదు అంటే ఏంది, ఎప్పుడైతే మనకు ఎర్త్కేక్ సంభవించి అక్కడ నుంచి ఎర్త్కేక్స్ వేవ్స్ ఆ మిషనరీ దగ్గరికి, అంటే ఇన్స్ట్రుమెంట్ దగ్గరికి వెళ్ళి ఆ ఇన్స్ట్రుమెంట్ పైన ఈ రికార్డ్ అయితేనే మనకు దాని వాల్యూ ఎంత అయింది, దాని ఎంత మొత్తంలో ఎనర్జీ రిలీజ్ అవుంది, ఎంత మొత్తంలో లాస్ జరుగుతుందని చెప్పగలుగుతాం. అంటే ఏంది, ఎర్త్క్వేక్ సంభవించిన తర్వాత సో వాట్ ఈస్ ద అమౌంట్ ఆఫ్ డిస్ట్రక్షన్, వాట్ ఈస్ ద అమౌంట్ ఆఫ్ ఎనర్జీ హాజ్ రిలీజ్డ్, ఈజ్ ఇట్ మైనర్ ఎర్త్క్వేక్స్ ఆర్ ఇస్ ఇట్ మేజర్ ఎర్త్క్వేక్ ఆర్ ఇస్ ఇట్ గ్రేట్ ఎర్త్క్వేక్స్ అని మనం చెప్పగలుగుతాం. కానీ we can't estimate before going to occur or before takes place the earthquakes. And that much of technology not there. So once earthquakes are occurred, or earthquakes suddenly takes place, already defined. I define the earthquakes. Earthquakes are the sudden vibration. Earthquake is a sudden vibration takes place which is on the earth surface. Sudden ga jarutundi. So unexpected ga, unnoticed గా జరుగుతుంది. సో దట్ we can't able to estimate. ఎప్పుడైతే ఎర్త్క్వేక్ జరుగుతుందో జరిగిన తర్వాతనే ఎర్త్క్వేక్స్ వేవ్స్ ఆర్ పాస్. The earthquakes waves are pass to the where which is going to be mostly to the instrumental zones or where we installed the instrument. At that places they are going to be reached, and then after on the rotating drum on the scale it is going to be calculate the amount of energy or magnitude, so that only it depends upon on the scale it is reported as 4.5 or 5.5 or 6.5 or 7 or 8, then only we can estimate the type of earthquake. Is it very dangerous or very severe or very normal? So that based on that value we are going to be estimate. So this is about the earthquakes. Okay, very important. Essay type questions definitely comes from either volcanoes or earthquakes. So only thing is you need to remember first to define the earthquakes and terminology. What is focus? What does it mean by focus? What does it mean by epicenter? And what does it mean by isosysmal lines? And what does it mean by earthquake's intensity? So these four terms you should define first. Or if it is not comes from essay question, even short questions also ask. What does it mean by define the focus and epicenter? Okay, what does it mean by isoseismal lines or earthquake's intensity or Richter scale. So there are several questions. Write about the earthquake's waves, P and S and L waves. Like there are so many questions. Then write about the classification of earthquakes based on the mode of origin, based on the depth of the focus, isn't it? So in such a way, there are several questions can scope to come from this chapter. So I hope you understand very well. So be prepared well. And once you read, if you have any doubts, you can ask even in the next class also. Okay, yeah, my class is over. Any doubts?
No, sir.
Is it clear, all of you?
Yes, sir.
Clear, sir.
Yeah, right. Thank you, all of you.
Thank you, sir.